All right, pre-calculus group. Today we're looking at single and double absolute value equations. And I'm going to show you a new method as to how to solve them. So we're going to be solving them by what's called the definition. And actually, this is part one. This is going to be a long video, so I'm going to make it into two parts. Okay, so part one. So first of all, rules. So first of all, by the definition, remember, definition of absolute value is the distance from zero. How far are we from zero on the number line? So with that said, that's what we're going to do. We're going to set up regions based on where those absolute values are equal to zero. So we're going to determine where the absolutes are equal to zero. What does that mean? So when I look at this equation right here, number one, where does this part right here equal zero? Okay? So I'm going to set my number line up. I'll do it over here. I want to set my number line up. And this absolute value is equal to 0 when x equals -3. And if you're not sure, x plus 3 equal to 0, x equals -3. So that means -3 is our dividing line. Everything to the right of -3, this will become a positive result. Anything to the left of -3, this will become a negative result. So that means when x is greater than or equal to -3, everything in here is positive. So x plus 3 plus 5 equals 2x. And then when x is less than -3, everything inside here is negative. So negative parentheses, and I got my plus 5 equals 2x, x plus 3. Now notice, with my inequalities, one I put strictly less than, one I put greater than or equal to. The side that you do that on does not matter because you have to include -3 somewhere. Okay, so now we've created our two equations. Remember when we did our absolute value problems the other day that I always made the side on the left the negative absolute, and then on the side on the right the positive. There's a reason. This is why I did what I did. The negatives were on the left, the positives were on the right. Okay, now I have my two equations to solve. Okay, so the only difference that we did, the only thing that was different is doing this number line idea. But there's a reason why I did that, this number line idea. Okay, so I'm going to solve this one over here. So I'm going to subtract x, combine my terms. So I have 8 is equal to x. So I subtracted x, I get x. I combine, I get 8. So there, x, 8. I got x equals 8. Okay. Now over here, I'll distribute. And then I'm going to add x. I'll combine those. So I combine this, I get 2. And I add x, I get 3x. Now I divide by 3, I get x equals 2/3. Okay, now, remember the other day we had to do checks, okay? So let's see. Determine where the absolutes are equal to 0. Number 2, we define the regions on the number line. So I define the regions on the number line. This is defining the regions. I set up equations based on the regions. That's what I did. I set up the equations based on the regions. Solved, we did that. Check. Now look at the check here. The other day when we did the checks, we actually had to plug in. I had to plug in 8 into the original equation. I had to plug in 2/3 into the original equations. That's a pain in the butt. I don't have to plug in anymore. Okay, here's the question that you have to ask yourself when you do the check. Is the solution in the correct region? Well, is 8 on the correct side over here? Yes, when we did this equation over here, when we solved this, we came up with x equals 8. That is on the side when x is greater than -3. So this is a keeper. But look at 2/3. Okay? On this side over here, x's are supposed to be less than -3. So this answer is supposed to be less than -3, but it's not less than -3. It's in the wrong region. So we cross it out. There's your check. 2/3 is not less than -3 here, so we can't keep it. There's only one answer. X is equal to 8. Okay. That's the nice thing about doing this number line. All right, now we're on number 2. All right, number 2. So I'm going to start by establishing my number line. Okay, there's only one absolute value, so I have a left and a right side. All right, so first of all, I got to know when does this equal to 0? Well, hopefully you can do that in your head, and you're going to see that it's -5/2. Okay, if you're not sure, okay, determine where this absolute's equal to 0. There it is right there. 2x plus 5 equals 0. You get left with -5/2. Now we're going to define the regions. So to the right, x is going to be greater than or equal to -5/2. Remember, -5/2 is a -2.5. And then to the left, x has to be less than -5/2. So I've established my two regions. So on the right-hand side, this is positive. Oops, I don't need the absolute values. And on the left-hand side, this is negative. So negative the parentheses. So now I have my two equations to solve. All right, so what am I going to do here? I'm going to subtract this x, and I'm going to subtract 5 the other way. So I'm going to subtract x. I get x. I'm going to subtract 5 the other way. That gives me a -4. Okay. I'll do my checks after. I mean, you can do your checks now if you wanted to. Here I'll distribute. I'm going to add 2x to the right. I'm going to subtract 1 to the left. So I'm going to add 2x gives me a 3x. Subtract 1 gives me a -6. Now I'm going to divide. Okay. So we came up with our solutions, our possible solutions, our potential solutions. Now I'm going to do my check. Are these in the correct region? So here we go. On the right-hand side, our answers are supposed to be greater than or equal to -2/5. -4 is not bigger than -5/2. So this is not an answer. All right, now -2 is -2 in the correct region? So is -2 less than -5/2? No, it is not. Remember, -5/2 is a -2.5. So -2 is in the wrong region. -2 is not less than -2.5. So this is not incorrect either. So therefore, this has no answers. Empty set. Okay? Empty set. Okay? So that's how easy these are to do. Using this method, you just made yourself, you've established an easier way to do your check. Okay? So our setup is doing the same thing. It's just creating these regions. Okay, one part positive, one part negative. Okay. The double absolute is going to be for part 2. So when you guys get your homework, you can start doing the part 1s, and then the next day you can do the part 2s. Okay. Okay. So now we're going to look at some inequalities and some of their uniqueness that we have to worry about. Okay. So the rules are still the same. Remember, we're going to do our one part positive, one part negative. In the first homework that we, so let's just do this first one, and then we'll look at these at these other ones, the uniqueness of the other ones. Okay, so here's my number line. There's only one absolute value, so that only creates, I'm going to put one spot here in the middle. So when is this equal to 0? That's right, 4/3. Okay. Now, so x will be greater than or equal to 4/3. X will be less than 4/3. So to the right, this is greater than. So this is positive, so everything coming out of here is positive. So 3x minus 4 is greater than or equal to 2. And then to the left, it's negative. All right, so I'll add 4, and then I'll divide by positive 3. So 3x is greater than or equal to 6. I divide by a positive 3. So I have x is greater than or equal to 2. Okay, now here I'll distribute. So I have a negative 3x plus 4 is greater than or equal to 2. Then I'll subtract. And then I'll divide. Remember, when you divide by a negative, your inequality has to do what? That's right, flip. So we're going to flip this once we divide by negative 3. So I have x is less than or equal to 2/3. Okay. Now we got to remember, with an inequality, we have to graph and state the solution set. So now here's the graphing parts. It's easy. I already have a number line up here. 4/3 is in the middle of my number line. Where is 2? So first of all, is 2 on the correct side? Yes, 2 is greater than 4/3. So graphically, I'll put 2 right here. Put a big fat, well, I will use a solid dot for 2. And that graph goes this way. So there's my graph. I can start looking at my graph right now. 2/3 is less than 4/3. Remember, 4/3 is like 1.3. 2/3 is 0.66. So 2/3 is in the correct region. So I'll put a big fat dot here for 2/3. All you got to do is just put it somewhere to the left, somewhere to the right. So here's my 2/3. And that arrow goes this way. So now you have the graph done. There's your graphs. And we got your gap in the middle. So this is your OR statement. Okay, so I'm using my interval notation for my solution. Negative infinity, comma, 2/3, bracket, because it's the equal sign, remember? Union, or. If you ever see it in a textbook, I'm writing out the word or. If you ever see it in a textbook, you would see this symbol. Looks like a U. Union means or. And then I have my bracket 4/3, bracket 2, comma, positive infinity. So there's your solution set. So this saves us the trouble of doing an extra graph. Okay? Sorry about this, got a little squishy in there, but you get the idea now. All right, so when you guys did your inequalities in the homework, the last homework, there are no other extra mysterious x's or y's popping up. In my next problem here, we have an extra letter involved. Okay? So with that said, now we have to be careful of how we write our answers out. Unique things happen when you start getting extra letters in there. So let's look at this. So here's my number line. Here's, I'll put 1 in the middle, because that's right, that's when that's equal to 0. So y is greater than or equal to 1, and this side will be y is less than 1. So to the right this is positive, so right, y minus 1 is less than 3y. And then to the left, we have inside here as being negative. So negative the parentheses, y minus 1 less than 3y. So I'll solve this side first. So I have negative y plus 1 is less than 3y. I'm going to add 3y. So I have 1 is less than 4y, or y is greater than 1/4. I'll write this out so what you guys are used to seeing. Y is greater than 1/4. So left to right. Y is greater than a quarter. Y is greater than a quarter. Okay? Because I added y to the right. Okay. All right, here. I want to, no, all right, whatever. So I'm going to subtract y. So I have negative 1 is less than 2y. I subtracted y to the right. Now I'll divide by 2. So y is greater than negative 1/2, or 1/2 is less than y. So I'll write that out properly for you guys. Y is greater than negative 1/2. Okay, now let's start interpreting these. This is the interpretations you got to be very, very careful of. So there is a check, but there's also an interpretation of what these mean on the number line. Okay? Because notice these inequalities are going in the same direction. This is saying y is greater than negative 1/2. This is saying y is greater than a quarter. That didn't happen over here when we did the straightforward inequalities with no mysterious extra letters popping up. All right, so what does this mean? So first of all, y is greater than a quarter. Well, here's 1 right here. It's certainly on the correct side. So here's a quarter. And according to this, a quarter, according to this, first of all, open circle, greater than a quarter, all the values greater than a quarter, so it goes in this direction. And I'm going to stop right here, okay? I'm going to stop right there because this is our imaginary wall. Because everything after this, okay, is outside of this region, over here. So I'm going to stop right here at the wall. So according to this over here, y is greater than a quarter only has solutions from the quarter, open circle, stopping at 1. I technically stop right here because now I'm outside the region. Okay, so the question is, do we catch this region based on this answer? Well, this is saying y is greater than negative 1/2. Now wait a minute though. Negative 1/2 is in the wrong side of the region, because negative 1/2 is not greater than 1. But where does it land in what direction of the arrows? So negative 1/2 is way over here. Here's negative 1/2. Open circle. But which way does it go? It goes to the right. Y greater than negative 1/2 goes to the right. What does that mean? Well, everything, I'll draw the arrow. Everything to the right is greater than negative a half, okay? And then so in here it's still greater than, but then all of a sudden I'm going to the right, I hit 1, and it keeps going, okay? But is this part over here a solution? No, it's not a solution, because this up until 1/4, this answer, there's my 1/4 right there, I'm covering it up. Y greater than a half doesn't exist over here. It's in the wrong side, okay? It doesn't exist. This only exists, so over here it does not exist. I'm going to scribble it out. This y greater than negative 1/2 solutions only exists after 1. We've included it. So this technically does not exist as an answer. Our only answer is y greater than 1/4. That's a little confusing. It's all this part of this interpretation. Negative 1/2 was on the wrong side, but it went in the correct direction according to this y is greater than 1/4. So we kept the y greater than 1/4, and then we kept the rest of y greater than negative a half. Okay? So our solution then only is y is greater than 1/4. Anything between negative a half and 1/4 does not exist. That's just how we do the solutions here. Okay? That's the uniqueness about these inequalities. Okay, so here's our solution. Y is greater than 1/4. If you want me to write that out as interval notation, that would look like this. 1/4, comma, infinity, parentheses, parentheses. This would be your solution. Actually, all right, these are both your solutions. That's unique. We've never seen that before. All right, let's look at this one now. 2x plus 5 is less than x plus 1. Okay, where is this equal to 0? Let me get this out. So when is that equal to 0? Yes, negative 5/2, or 2.5, a negative 2.5. So x is greater than or equal to a negative 5/2. X is less than 5/2, negative 5/2. So to the left it's negative, so negative parentheses 2x plus 5 less than x plus 1, and then positive over here on the right. So I'll solve this side over here. So we have a negative 2x minus 5 less than x plus 1. And then what am I going to do here? I'm going to add 2x, subtract the 1. So I have negative 6 less than 3x. So I divide by 3, I have negative 2 is less than x. So x is greater than negative 2. And we'll do the interpretations in just a second. So subtract x, subtract 5. So I have x is less than negative 4. Okay, now what do these mean? What do these mean as answers? So first of all, let's start with this one right here. X is greater than negative 2. Negative 2 is not in this region, but does it shade towards this region? No, it does not. X is greater than negative 2 is over here, and it shades to the right. So that's totally wrong for us. It doesn't go in our region at all. So this does not exist. This is not an answer. All right, negative 4. So this does not exist. Negative 4 is over here to the left, and it's shading in the wrong direction. It shades to the left. Okay, so that doesn't even cover its region. So we have nothing covering our regions then. or up, remember up over here, the negative 1/2 went towards its respective region. So we could keep part of it. We could keep the 1 and above. So we could have just this y is greater than 1/4. Here, negative 2, and x was greater than negative 2, does not even cover this region, the region to the left here. X is less than negative 4 doesn't even cover the region to the right. So this does not exist either. So this has no answers. Has no answers. Empty set. Okay? Because x was, when we did the less than part, we had no answers. All right, now I want to show you something unique. Very unique. What happens when I flip the inequality over? Notice I flipped the inequality over and I made it a greater than or equal to. Okay? So we have all the work right here. So all I'm going to do is just draw my number line. So it's the exact same question. I just flipped the inequality over and I included an equal sign. Well, the reason why I included an equal sign because I wanted to make sure I included negative 5/2. Got to include it somewhere. Okay. Alrighty, so here's my negative 5/2. So here, over here is the region. Over here is the region of x was greater than negative 5/2. Here was the region x was less than negative 5/2. Okay. Here, x was less than or equal to negative 1/4. Here, x was greater than or equal to negative 2. All right, now look at what happens. Oh, no, I made a mistake. I got to scribble out these inequalities. These inequalities are wrong. Here, let me do this again. I flipped this inequality, so each of these inequalities get flipped. That my final answers get flipped. So this is x is greater than or equal to negative 1/4, and this was x is less than or equal to negative 2. There. Once I flipped this inequality, these two answers got flipped. Okay. All right, so we got that fixed. All right. So now, negative 4 again is on the wrong side. Here's negative 4 right here. Closed circle, and it goes to the right, but it only exists after the negative 5/2. So this right here only exists from negative 5/2 to the right. Okay? So all of this going to the right. So over here it doesn't exist. Negative 2 is over here, and it goes to the left. Well, it doesn't exist on this side, so all of this over here doesn't exist for the negative 2, but it does exist everything to the left. Okay? So even though it was on the wrong side, it was shaded towards our special region. So we kept everything to the left of negative 5/2. And then x was greater than negative 4 does not exist on the left-hand side, but it does exist everything on the right-hand side. So guess what? We've covered the entire left side. We've covered the entire right side. We've included negative 5/2. So this answer is all real. Okay, that's a very, very unique one. Okay, all right. So first part of your homework then is to at least do all the single absolute value problems. I think there's only 3 or 4 of the double absolutes on there, so we're going to save that lesson for tomorrow.